Hello everyone. So let us continue our discussion here in this course, specifically about gas turbine power plant. And our discussion for this lecture video will be focused on sample problems about Brayton cycle and gas turbine power plant. We have discussed on our previous videos about the parts of a gas turbine. As you can see in this picture, it has intake, compression, combustion, and exhaust. This is another picture of the schematic diagram of the gas turbine. And we have also discussed the classification of gas turbine and also the equations we will be using in solving problems about Brayton cycle. So we have here the PV diagram. It starts with isentropic compression 1 to 2 and heat addition 2 to 3, expansion process 3 to 4, and so on. So we have already discussed the equations for finding the heat added, heat rejected, the turbine work. This turbine work here is the gross work of the turbine because some parts of the work of the turbine ay napupunta siya sa generation of power if it is used in power plant, and some work of the turbine is being utilized by the compression of the air from 1 to 2. We have also discussed the efficiency, that is the work net divided by the input Qn, the heat added, and the pressure ratio. This is simply the ratio of P2 or P3 divided by P1 or P4 because P sub 2 and P sub 3 are equal and also P sub 1 and P sub 4 are equal. So pressure ratio is equal to P2 over P1 or P3 over P4. We have also discussed the efficiency of the Brayton cycle, which is equal to this equation, and to find out the work of compression and expansion. So since this is isentropic compression and isentropic expansion at constant entropy, then the equation should be WP or WT is equal to P2B2 minus P1B1 over 1 minus K. So if we use the equation of the gas law, PB MRT, we substitute this PB MRT2 and this P1B1 MRT1. So these two equations are equivalent. Now let us discuss the first example. In this example, it is stated that calculate the work done per kilogram of gas expanding from 6.33 kilogram per square centimeter absolute to 1.05 kilogram per square centimeter absolute in a gas turbine. Initial temperature is 750 degrees Celsius. Use K or the specific heat ratio equal to 1.34 and the molecular weight of air equal to 29. Now may I present again the process. So in a gas turbine, fresh air is being compressed at the compressor, then heat is added in this process 2 to 3 during combustion, and from 3 to 4 the gas expands in the turbine and then the exhaust gas is being released in the atmosphere. This is for open cycle. So as you can see here, the turbine is used to drive a shaft to deliver the work, and this turbine also is being utilized to drive the compressor. Now the given value here is T3 because this one is the initial temperature referring to the initial temperature of the gas expanding. So ang pinag-uusapan kasi dito ay yung the process from 3 to 4. So calculate the work done per kilogram of gas expanding from. So the starting process is 3 and the final process is 4. So we have here T3 is equal to 750 Celsius To convert it to Kelvin, we add 273. And the pressure at the start, so that is 6.33 kilogram per square centimeter. This is the pressure here of the start of the expansion process. So that is 6.33 kilogram per square centimeter absolute. So this is in MKS units. So meron kasi tayong tinatawag na MKS units noon. So we have SI units, we have English units, and we have also these MKS units, meter, kilogram, second, MKS. So the unit of pressure in MKS unit is kilogram per square centimeter. Now you can convert this into PSI and into kilopascal absolute. So you divide this one by 0.0731 kilogram per square centimeter per PSI. So this is a conversion of units from kilogram per square centimeter to PSI. So ang ibig sabihin nito, 1 PSI is equal to 0.0731 kilogram per square centimeter. So that's why we have here PSI A. Now to convert it to kilopascal, there are so many ways. You can use this 101.325 kilopascal per 14.7 PSI, then you will have 596.88 kilopascal. You multiply this by 101.325 and divide by 14.7. So yung 101.325 kilopascal and 14.7 PSI are equivalent atmospheric pressures. So that is how it is being converted here. So I hope I have already told that to you, how to convert pressures from English to SI units. Now this graph shows the values of CP, CB, and K. I have put it here just to clarify why we are using here K 1.34. If K is not given, I'm always telling you that you can use 1.4 as the value for K if that is not given in the problem. So K here is 1.34 because we are assuming that the temperature of the gas is at the average of 900 Kelvin. So now, how do we will get the work done per kilogram of gas? Now, the work done of the turbine, we are speaking only here of the process 3 to 4. So regardless of other process, we are concentrating on this process 3 to 4. Ang sabi dito, calculate the work done per kilogram of gas expanding from 6.33 to 1.05 in a gas turbine. So the initial temperature is 750. So we have converted that here already. So because this process 3 to 4, the expansion of gas on the turbine is isentropic, the correct equation for turbine work is this one. WT is equal to MR times the change in temperature divided by 1 minus K. So M here is the mass, R is the gas constant. So ang problema lang natin dito is the value of T4 since we have T3 and we have already the value of K. So dalawa lang ang hanapin natin, yung R and T4. So how about M? So kung makikita kasi nyo dito, calculate the work done per kilogram, right? Work done per kilogram. So we will be assuming here this is a unit mass. Okay, so we can assume that M is a unit mass. This is 1 kilogram. So kaya ang kalalabasan dito na unit, after we have solved this, dapat work per kilogram. So that is, if work is in Newton meter, so that is Newton meter per kilogram, or since Newton meter is equal to joule, so that must be joules per kilogram. So to find the value of T4, we will be using this equation. So this is the PT relationship for isentropic process. So, sinimplify lang ito. So, this is T over P raised to K minus 1 over K. Right? Kaya lang sinimplify siya kasi sa isentropic process, that P and T relation is T over P raised to K minus 1 over K. So, ito yun. Sinimplify lang. You can review this in thermodynamics, isentropic. So, in terms of T4, we have T4 is equal to T3 times the quantity of P4 over P3 raised to K minus 1 over K. So, kung makita nyo na baliktad kasi this is the result of the simplifying this equation into this one. So, this is algebra. Now, what is R? R now is equal to the universal gas constant 8.314 kilojoules per kilogram mole Kelvin divided by the molecular weight of the gas. So the molecular weight is 29. So 29 here means kilogram per kilogram mole, or pwede rin siyang, kung English, 29 pound per pound mole. So kaya dito wala siyang unit kasi you can put that kilogram per kilogram or pound per pound mole. So you divide this one, you get the specific gas constant. So this is the universal. So this is the specific gas constant specifically for air. 0.28669 kilojoules per kilogram Kelvin, or this is also being used most of the time. This is equal to 0.287. And solving for T4 using this equation, we have substituted the value of T3, 1023, the value of P4, this one, 14.364, and also the value of P3 here, raised to 1.34 minus 1 over 1.34. We have here T4 is 648.501. Now, always be aware of this one. So, this is the 0.3 and this 0.4. So, ang tip ko sa inyo dyan, ang temperature at 3 must be always higher than 4. So, pag ang answer nyo dito sa T4 ay higher yung nakuha nyong answer sa 4 kaysa sa 3, sigurado ko mali yung sagot nyo. Right? So, tingnan yan. T3 is 1023. So, this is higher than T4 kasi nasa graph nga, mas higher siya. 648.501 lang yung T4. Then, we substitute these values. T4 here. We substitute the value of R here. So, ito na yon. And T3, ito yan. And then, the value of K, we got here, WT is 315.78 kilojoules per kilogram. So, makikita nyo kilojoules per kilogram kasi ang sabi dito, calculate the work done per kilogram. So, this is work per kilogram. Now, if you want to solve further for the properties on every point, so pwede mo siyang isolve using these equations. So, kung nire-require ka, halimbawa, ang nire-require sa'yo is solve for specific volume at 0.3. So, pero wala siya dito sa problem. So, idadagdag ko lang, halimbawa, how to find the specific volume of each point, 0.1, 2, and 3. So, ganito ang gagawin mo. Gagamitin mo yung mga equation relating PB kasi meron siyang volume. So, PB raised to K is equal to constant. Dito yan. 3 to 4, that is P3, B3 raised to K is equal to P4, B4 raised to K. So, that is the equation. Also, you can use 1 to 2. So, papalitan nyo 1, dito 1, ito naman ay 2 and 2. So, magagamit mo lang yan dito sa 1 to 2 and 3 to 4 kasi mga isentropic. From 2 to 3, hindi mo pwedeng gamitin yan kasi kukunin mo yung equations naman at constant pressure. So, nandun din yan sa thermodynamics. And also, at every point, ito ay madalas ko na itong sinabi, kasi we are assuming that the gas is a ideal gas. So, you can use the ideal gas law. PB is equal to MRT at any point. Pwede itong 1, 1, and 1. Pwede siyang 2, 2, and 2. So 3 yan. So pwede rin siyang 4, 4, and 4. You can use that equation at any point. Okay, so paparesan naman lang siya ng mga subscript. Now, since we are looking for point 3, so assuming we are looking for point 3, the specific volume, so we can compute this one by using this equation. So since unit mass tayo, di ba, walang mass. So walang mass na given, yung M dito, ilalagay mo lang siya dito sa ibaba, right? And yung P3, ilalagay mo dito. Kung makikita nyo, yung B3 over M, M here is constant ang value niyan. So, ang M1 is equal to M2 is equal to M3 is equal to M4 kasi mass yan. Right? Tatandaan nyo, mass yan. M1 is equal to M2, M3, and M4. So, wala naman kasing naghalong mass na iba. So, kung ano yung nasaksyon ng compressor, yun ang dumaan sa 2, yun din ang dumaan sa 3, at yun din ang lumabas. So, that is the mass of air. So, no need for the subscript. So, B3 over M is equal to the specific volume at 3. The volume at 3 divided by M is equal to the specific volume of 3. So, pag sinabi natin specific, the unit is cubic meter per kilogram or cubic foot per pound. Specific, may per siya. Samantalang itong V, cubic foot lang siya or cubic meter. So, these values are retained. So, alam natin yung R, alam natin yung T3, alam natin yung P3, right? So, we can now solve for the specific volume of 3, that is 0.491 cubic meter per kilogram. And you can also use these equations to solve for specific volume of 4, 1, and 2. So, nasa sa nyo lang, imamanipulit nyo lang yung mga gas equations. Sample problem number 2. The gas turbine of a power plant operating on Brayton cycle delivers a gross power of 15 megawatts. What is the mass flow rate and the volume flow rate of air entering the turbine if the minimum and maximum pressures are 100 kilopascal absolute and 500 kilopascal absolute respectively, and temperatures of 20 and 1000 degrees Celsius? So the given here is the T1. So bakit 20 ang T1? Kasi ito yung tinasabi natin na maximum and minimum. So the minimum temperature is 20. So nasaan yung minimum temperature niya? So siyempre yung nasa suction ng compressor. So kung makikita niyo dito sa schematic diagram, so ang sinasuction ng compressor ay fresh air. So this is the temperature that is lowest in the cycle. Kasi fresh siya fresh air. So this is atmospheric temperature and atmospheric pressure. So T1 is 20 plus 273, that is 293 Kelvin. Now, ito namang 1000 degrees Celsius, ito yung maximum temperature. So saan mo ito makikita, yung maximum temperature? So sa PV diagram, makikita mo yan siyempre sa point 3. Right, bakit sa point 3? Okay, kasi kung ipa-plot nyo ang temperature dito sa PV diagram, this is the highest between these points. At kung makikita nyo uli, doon sa schematic diagram, so nasaan ba dito ang highest temperature? So of course, pagkatapos ng combustion, diba, kasi ma-add ka ng heat. So pag nag-add ka ng heat, tataas yung temperature, so nasa point 3. Ito, naka-expand na siya, medyo lalamig na yung temperature niya, so mas malamig ang 4 kaysa sa 3. So ganon yun. So this is your highest temperature here. So that's why we have assigned T3 is equal to 1000 degrees Celsius plus 273, that is 1273 Kelvin. So in this one, I again use K is equal to 1.34. Right? So this is only my solution. Kasi ginagamit ko kasi itong 1.34 because I am referring to the average temperature of the cycle. So, makita nyo kasi dito sa K, so if you have a temperature of about 900, the average temperature of air, K is equal to 1.344. So, it is safer to use 1.34 instead of 1.4. Right? So, ang 1.4 kasi, this is atmospheric temperature. 300 Kelvin. But, sinabi ko nga, kung hindi given, ang value of K, you can use 1.4 in your solution. That is correct also. Now, the minimum pressure is 100 kilopascal. Again, nasaan yung pinakamababang pressure? Siyempre, nandito sa 0.1 because this is atmospheric. And the highest pressure, as it is shown in the graph, is at 0.2 and 3. So, 500 kilopascal. Now, to find the mass flow rate and the volume flow rate of air entering the turbine, so, titingnan nyo ang sabi dito, air entering the turbine. So, ibig sabihin dito, anong point ito? Anong point ang dapat isaalang-alang natin? So, 0.3. Diba? Kasi this is the point of air entering the turbine. Anyways, yung mass flow rate, kahit saan mo isolve, para-pares lang yan. Pero, magkakaiba yan pagdating dito sa volume flow rate. Kasi, ang volume flow rate ay magkakaiba-iba yan sa mga points na yan. Ang mass lang ang para-parehas yan. Now, we can use this equation. WT is equal to MR times delta T divided by 1 minus K for this process, 3 to 4 isentropic. And this again is the PT relationship for isentropic process. So, since given yung P4, so what is P4? What is P3? So, P4 is equal to P1. P3 is equal to P2. So, kung makikita nyo sa graph, di ba? Equal yan. So, we have here 1273 times this quantity. We solve for T4 equal to 846.209 Kelvin. So, again, to check, T4 must be lower than T3. So, T3 is 1273. T4 is 846. So, tama tayo. This can never be higher than T3. Now, to solve for M, we can manipulate this equation, convert it in terms of mass. Ito yung conversion niya. Then, you substitute the value. So, meron ditong 15,000 kilojoule per second kasi ang sabi dito is 15 megawatts. So, 15 megawatts is equal to 15,000 kilowatts. But kilowatt is kilojoule per second. So, I write this here para nakikita ko yung cancellation ng mga units. Kasi kung kilowatts yan, parang malilito ka. Paano makakancel yung kilowatts kasi may kilojoules. So, kaya nilalagay ko yan. Instead of kilowatts, I use kilojoule per second. So, para malinaw sa akin na tama yung lalabas na units ko. Then, we have here, M is equal to 41.681 kilogram per second. So, ito yung mass flow rate. Now, this M here, again, is true in all points. This is M1, ito yan. M2, ito rin yan. M3, ito rin yan. M4, ito rin yan. Hindi yan nagbabago. Pero pagdating sa volume, magbabago-bago yan. Iba ang B3, B4, B1, and B2. So, since we are solving for volume flow rate at 3, so we use this equation, B3, the specific volume, okay, ito yung na-derive natin sa first problem. Here, right? So, paano natin na-derive yung specific volume? We just copy that here. B3 is equal to RT3 over P3. Then, substitution of these values are, so we use 0.287 kilojoules per kilogram. T3 is 1273 and 500 kilonewton per square meter. So, ano naman ito? Bakit naman to kilonewton per square meter? So, P3 is in kilopascal absolute, right? So, this one, P3. So, this is also equal to P2. So, 500. So, kilonewton per square meter kasi ang Pascal is Newton per square meter. So, why I use this one? Kasi ako sabi ko nga, gusto kong nakikita ko yung anong kinakancel ko sa mga units. Pero makikita nyo dito, meron ditong kilojoule ito kilonewton. So, ang joule kasi is newton meter, di ba? Kilonewton meter. So, yung kilonewton dyan makancel. Right? Yung Kelvin dito, makancel din. Kasi meron dyan ditong Kelvin. Ilalagyan ko kasi kulang yung units ko dito sa R. Here we are. Okay, so meron na siyang Kelvin. So, Kelvin and Kelvin will cancel. Yung kilonewton dito, makancel yan sa kilonewton dito kasi itong kilojoule is kilonewton meter. So, what is remaining is square meter multiplied by the meter here. So, cubic meter and kilogram. So, that is specific volume 0.73 cubic meter per kilogram. Now, to find out the volume, okay, the volume flow rate. So, this is the specific volume. This is not the volume flow rate. So, tatandaan nyo, pag sinabi kasing flow rate, per unit time yan. To find this one, the volume flow rate per unit time, so you can use this equation. V3 is equal to M times the specific volume at 3. By substitution, the mass flow rate, right? So, this is mass flow rate. Here, kilogram per second times the specific volume. We have here the volume flow rate in cubic meter per second. So, the answers will be this one, 30.424 and 41.681 kilogram per second. Now, let's go to this another example. An ideal gas turbine operates with a pressure ratio of 10 and the energy input in the high temperature combustion chamber is 300 kilowatts. Calculate the airflow rate for a temperature limits of 30 and 1200 degrees Celsius. I found this problem in a passboard examination, including this one. This problem number 2 is also from passboard examination, and this is also from passboard examination. So again, importante yung alam nyo yung schematic and the PV diagram. So para ma-drawing nyo kung nasaan itong mga values na ito. So sabi dito, calculate the airflow rate for a temperature limits of 30 in 1200. So ibig sabihin ng temperature limits, this is the maximum and minimum temperature in the cycle. Right? So nasaan yung 30? So siyempre yan, dito yan sa fresh air, sa suction. Nasaan naman yung 1200? Siyempre, after decombustion. Nandito yung pinaka-maximum temperature. So, ipa-plot mo. Then, the pressure ratio is 10. That is P2 over P1 or P3 over P4. The energy input in combustion chamber is 300 kilowatts. So, ito yung QA. Q added. 300 kilojoule per second. So, ganun ang pag-plot. Temperature of 1. The temperature at 0.3. So, this one, I use the K value of 1.4. So, kasi hindi naman siya given, so I will just using that. And you can also use other values. You just have to justify that. Pero dun sa mga quiz natin kasi, ang palagi kong instruction sa quizzes, pag walang given na condition, you use the standard values. Halimbawa, pag hindi given ang pressure, kung anong condition niya, kung anong elevation, you use the pressure at the sea level, 14.7. So, ganun din yung value ng K. Pag hindi given, hindi naman sinabi, you use the standard air, 1.4. So, the pressure ratio is given, P2 over P1 equal to 10. Now, here, we will be using here, QA is equal to MCP delta T. So, bakit hindi tayo gumamit dito ng yung equation for isentropic? So, siyempre, this one is Q added. So, this is MCP delta T. So, this is Q added at constant pressure. This one, 2 to 3, constant pressure. But to find the temperature at 2, you will use this formula. So, this is isentropic formula uli. Kasi from point 1 to 2, this is isentropic. So, T2 is equal to T1 times P2 over P1 raised to K minus 1 over K. So T1 is 303. So P2 over P1, given po yan, 10. So you just substitute the value of K. Then we have here T2 is 505.001 Kelvin. So this is your point 2. So bago magkaroon ng heat addition. So now, since alam na natin yung temperature after heat addition, 1473, we just substitute that in this equation, solving for M. So, kasi nandito, calculate the air mass flow rate. So, we have here QA over CP T3 minus T2. And we have here 0.336 kg per second. So, ito yung answer. So, sabi ko nga sa inyo, you should look also for these values, lalo na yung temperature. So, makikita nyo uli yung temperature, di ba? Ang T1 is 303. So, siyempre, itong pinakamababa, T2 is 505. After compression, siyempre tataas yung temperature. Then, after heat addition, tataas uli, di ba? 14.73. So, kung ititrace nyo yung PV diagram, yung temperature sa PV diagram, tama yung sequence, di ba? Mababa, tumaas, mas tumaas dito sa 3. Then, mababa uli yan dito sa 4. So that is our lecture for this video. We have here 3 examples. Marami pang pwedeng i-discuss about turbine. Example, finding the efficiency. So, you use the equation for the efficiency. Halimbawa dito, kung may problem is find the efficiency, this will be your equation. Now, the turbine work can be also found using this one, Q added minus Q rejected, but this is being used in some special cases kung alam mo yung QR. So kung hindi mo ma-determine yung QR, you use the turbine work by the isentropic process 3 to 4. And also take note of this efficiency. Halimbawa, given ang net work and QA, the heat added, you can directly solve for efficiency. Ano tong WNet? Itong WNet kasi, ito yung the total turbine work minus the compression. Yung kasing turbine, part of it is delivered in the generator and part of it is used by the compressor. So the network, itong WNet, ito yung na i-deliver sa generator. Right? Ito kasi yung useful output. And this is your input. So, efficiency is output divided by input. So, anong useful output? Ito yung work na tinatanggap ng generator. Yung gross work na ginagawa ng turbine, that is being divided into 2. Some part of it is delivered to the compressor. So, itong WNet is equal to the gross minus the work of compression. So that is our lecture for this video. I hope you understand this one. Ito muna, salamat.